Bonjour, Cardinals. It's me, Mr. Ernst, and we are going to be looking at how to translate a graph. So we had arithmetic sequence, geometric sequence, and we're going straight into translating a graph. Now, we talked about translation beforehand, but we were usually doing it in terms of this guy, a little triangle. And what we were doing with the triangle when we translated, let's say triangle A, B, C, translating means we're just grabbing the shape and sliding it down to a new position. So for example, let's say we slide the triangle down here. Okay. That's going to give me A prime, B prime, and C prime, which is pretty nice. A's point comes straight down, B's point comes straight down, and C's point comes straight down. As a quick little review of that, when we're looking at these points, something else that we also looked at was, let's say point B right here was sitting at, we'll say 2, 2. So on the coordinate grid, let's say this was at 2, 2. And it dropped down, let's say by like 10. When we're translating, remember the instructions can be given to us in the form of x and y. In other words, what is happening to the x value and what's happening to the y value. In this case, the y value, b is going straight down, so the x value doesn't change at all. So we're going to say plus 0. There is no change to x. However, our y value is dropping by 10. So my y value is going to be minus 10. These are kind of like your directions, your cipher, your code to be able to translate the shape downwards. Directions, whatever you want to call it. So x plus 0 and y minus 10. If that's true, even though I'm not on a graph right now, I can figure out where b prime is. X plus 0, or in other words, 2 plus 0, and 2 for my y value is going to be minus 10. So I can find out my new point of b prime by simply doing the arithmetic here. 2 plus 0 gives me 2, 2 minus 10 gives me negative 8. So my new point for b prime is 2, negative 8. Cool? And that's just a quick review of that stuff. This is going to be important for us and very relative to what we're doing over here. So what we were talking about is we are going to not just be translating a shape, but instead we're going to be translating an actual graph. I want to emphasize the fact that our original graph is f of x, this one right here. F of x, and we're given the equation is equal to x squared. So we know each one of these is a quadratic graph because we're to the power of 2. So we have this black line here, which is x squared. That's our original function. The pink line has taken the graph and translated it up somehow. The pink line has moved all of the points up somehow. And the blue line has taken all of the points of x squared and moved them down somehow. And that's what we're going to be looking at today. How do we take x squared and move it up and move it down? Some of you guys, if you remember how the equation works, may already have an idea of how we're going to go about doing this. So we're going to switch over now from my little fancy-pantsy art over to Desmos. So looking at this problem on Desmos, right over here I have a generic quadratic equation. A times x squared plus bx plus c. Right now a is equal to 1, so this is essentially x squared. B is 0, so this is 0, and this is 0. So in other words, these ones are basically zeroed out, and a is 1. So in other words, this equation is actually just y is equal to x squared, which is where we started from before. I have these sliders in here because I want to show you which one of these is actually going to change it. Cool? The other equation that we had, actually I'm not going to put that in there because it's going to spoil it. The other equation we had, if I go back, the other equation that we did have, starting at 0 was our original. This one starts at 2. So let's see, how are we going to raise this up so that this quadratic equation can now start at 2? Going back to flipping back and forth. I am not super familiar with flipping back and forth between these. Sorry. There we go. So I want to raise this up so that this graph doesn't start here, but instead it starts right here at 2. Cool? So I have A, B, and C that I can mess with. If I start messing with A, which is the coefficient to x squared, when I start messing with A, I notice that my line doesn't get any closer to the number 2. It kind of causes it to bow in and outwards, where it kind of goes out, it flicks out over the x-axis, and then it flips downwards. Flicks back over the x-axis and then goes upwards. So that's not what I'm looking for. So I'm going to turn this back to 1. So it's not A. B is the value here. Right now it's zeroed out, so there's no change to B. But let's start changing the value of B and see if that does it. B is moving it, but you'll notice that the y-intercept is still staying right there, right at 0. It's not going up and hitting 2. Even if I came all the way down, even if I extended this out to, instead of just 10, if I extended this out to 100, it's going to get really close, but it's not what we're looking for. I want it to start the equation to just simply slide upwards. And it's not sliding upwards yet, so I know it's not B. I'm going to reset B to 0. So if it's not A, it's not B. Spoiler alert, must be C. Grabbing the slider for C, I can see this causes my shape to translate perfectly up and down. And if I wanted it to start at 0, C is equal to 0. If I wanted it to start at 2, C is equal to 2. We still don't have a B, so this is going to be x squared plus, if I'm starting at 2, this is going to be a 2, x squared plus 2. Going back over to the actual math page here. So once again, to kind of illustrate this, let me get that one thing out of the way here, this guy. We don't need this triangle anymore. What is this nonsense? Get at it. Get out of here. Okay, so once again, f of x, I'm going to write the equation out now with a f of x is equal to x squared. That's where we're starting, x to the power of 2. Our next one, let's say pink, is h of x is equal to, it's still going to be x squared, because we're still using the same equation, we're just finding a way to translate it, x squared. But because it's being moved up to 2, we know that it's going to change our y-intercept by 2. Oops, I put that in the wrong spot, sorry. Plus 2. Which means if I then come down and look at g of x, to slide it down to, this is -2, -4, -5. If I'm going to make this -5, g of x is equal to still that same x squared. We don't want to change that because remember that made it bow out, or it'd make it really skinny. Kind of look like this. This is going to be x squared minus, I'm starting at 5 minus 5, minus 5. So those would be the three equations for this. Original, sliding up by 2, and sliding down by 5. The way that one of the questions on the homework is going to ask you, it gives you a grid or like a table. It gives you a table and it asks you to go through and basically look at these different coordinate points. So I'm going to talk about those coordinate points really quickly so we can take a look at what those look like. We have x, we have f of x, we have, I'm going to put these back in alphabetical order, g of x, and we have the very last one, which is h of x. I'm going to take a look at all three of these one after the other. By the way, it makes me very happy that I have very similar colors to what's already on here. Makes everything look very aesthetically pleasing. So let's start off with 0. Your guys' table, I think, starts off at like -2 or 3 and 0 somewhere over here, but I want to start off at 0, so I'm going to start my table off at 0. 0. For x squared, 0 to the power of 2, 0 times 0 is just going to be 0. For g to the power of x, 0 times 0 is still 0, but now I have -5, so I'm starting at -5. H of x, 0 times 0 is still 0, plus 2. My x value for this next one, let's say the number's 1. So in other words, all of these are going to be 1 times 1. So in all of these, the x value is now going to be replaced by 1, 1, 1. My first one, 1 times 1 gives me 1. My second one, 1 times 1 is still 1, plus 2 gives me, oops, no, I was right. Okay, sorry, this is really messing me up. I'm going to switch these around real quick. That way, I'm not going to get confused anymore. Put these in their proper order. It seemed more logical to have it go up than down first, and that's where my demise was. There we go. There's a good order. Okay, sorry. So we have 1 squared, which is 1 minus 5. 1 minus 5 is going to give me 4. And then finally, 1 plus 2 gives me 3. Now, when we're looking back at those directions that I talked about earlier, I said we had x and our y, and that these kind of functioned as our directions, correct? For this one, for f of x, back of when these were x, back when this was x. When I'm looking at these, for f of x, there is no change. X is the same and y is the same because it's our original. For g of x, we have x and y, and this time our directions are, our x is still the same. Nothing's changing with our x, so this is still plus 0. However, our y value does change. Y is going to be minus 5. So instead of a y value of 0, I have to subtract 5 to get my new y value. Instead of a y value of 1, I have to subtract 5 to get my y value of 4. For my last one, h of x, my directions, or my code cipher, x is still not changing. For all three of them, x is staying exactly the same. That's because our graph is moving up and down. If our graph moved left and right, then x would change, but it's not doing that, so x is not going to change at all. My y value for this is going to be, when it's 0, we're adding 2 every time. So these are my directions. Original equation, sliding it down by 5, and sliding it up by 2. Cool? I hope this helped you guys out. Let me know if it didn't. And yeah, good luck on your assignment. Bye!